Welcome back for part 2 of chapter 12 in DE Chemistry, Chem 112. Woohoo! So when last we talked, we were doing some example problems talking about the cubic lattice structures from chapter 12. And I'd like to do one more with you. And again, this example is in your notes, and those notes are linked in Schoology for your viewing pleasure. Okay? So it says platinum crystallizes with the face-centered cubic unit cell. The radius of a platinum atom is 139 picometers. Calculate the edge length of the unit cell and the density of the platinum atom. Okay, so the first thing I'm going to do is calculate the edge length. Okay, and I know that because it is face-centered, and I would have to tell you what kind of structure it is from my notes, that length equals that formula, okay? So then I'm just going to plug and chug into my calculator that. You have to be given the radius in this problem to do that. It's 139 picometers. When I plug all of that in my calculator, I find that the length of that unit cell is 393 picometers. And because I'm going to look for density, which means that it's mass over volume, I'm going to want that length in centimeters because centimeters cubed is a milliliter, okay? So I'm going to go ahead and convert that to centimeters, okay? And by doing that, it will just make my life a lot easier when I go to find density. All right, so I know from geometry class that volume is equal to length cubed. And I know that density is mass over volume, so that's why I'm looking for volume now. And if the length is that cubed, then the volume is centimeters cubed or milliliters, which is what we want for a density problem. Now, density is mass over volume. I need to find out how much mass is inside that unit cell. Because it is face-centered from my notes, I know that face-centered equals 4 atoms. So I will convert atoms to moles. And then I can convert moles to grams. Now, because this is platinum, I look on the periodic table and I find out that platinum has a molar mass of 195. I plug all of this in my calculator. And now I have grams. So it makes finding density really easy. Density is just mass over volume. So there's my mass over volume. Plug and chug in my calculator. And I'm done. Okay? So I had to find two things here. I was asked to find the length, and I was asked to find the density. Okay? Now, the next part of your chapter talks about these crystalline solids and classifies them for us. And so there are 3 types of crystalline solids that are discussed in this chapter, okay? You have atomic solids, you have ionic, and you have molecular solids. Ionic's obviously going to be ionic bonds, so I expect there to be a cation and an anion, or a metal and a nonmetal. The molecular are going to be your covalent bonding systems, so they're going to be all nonmetals, and the atomic is just going to be one element, one type of element forming a solid structure. Now, we're going to first start talking about molecular solids. They are held together by really weak dispersion forces if they are nonpolar, and by dipole and possibly hydrogen bonds and dispersion forces if they're polar. They tend to have low MP. MP stands for melting points, okay? And they are poor conductors of electricity and heat. But that kind of makes sense to us, okay? The next type of solid that we're going to talk about are ionic solids. They are held together by these really strong ion-ion attraction forces. The positive and the negative are really going to be strong between them, those attractions. They tend to be hard and brittle. They have high melting points. And typically, the cation is smaller than the anion. And so when they stack together, the little tiny metals or cations can fit into the holes created by the anions. I'm not going to illustrate that for you on the board. You're going to need to look in your textbook for that. And the last type of example are atomic solids. Okay, there are 3 types that your book discusses. There's non-bonding, where you just have atoms held together by really weak dispersion forces. They have low melting points. There's metallic, obviously those are metals. They tend to have variable melting points, some high, some low. And then there's network, which are covalent bonds, which tend to have pretty high melting points. And then I ended the notes on this unit with a few examples. And I asked you to classify the crystalline solids and tell me what you thought they would be. The first one says AU, that's just gold on it. So I assume that's atomic. The next one is molecular, see, all nonmetals. And the last one is ionic. And I can pick that up right away because I know that calcium is a cation or calcium is a metal. Okay? This concludes your exciting notes on Chapter 12. Can't wait to see you in class so we can dive into it even more. Toodles poodles, have a good day. Bye.